Hi children, welcome to Easy Physics. Let us make physics easy. Today, I would like to discuss grade 9 physics, chapter 8, motion. Let us start with state of motion. In everyday life, we are observing movement of different objects, right? Moving a car, running a child, okay, and moving a chair. Different movement we can see that. Then what is motion, or what do you mean by that state of motion? Suppose you and your friend are traveling in a bus, okay? So while considering or with respect to your friend, you are not moving, right? Because both of you are sitting in same seat, right? So when you are considering that tree outside or a road, you are moving, right? How can we say that you are moving? So when we are comparing with others, that means your position is changing, right? So that is what is motion. So state of motion means if position of an object changes with respect to a fixed object, then the object is said to be in a state of motion, right? Example, a moving bus. Position of that bus is changing with respect to bus station or bus stop. Then we can say that bus is in a state of motion, right? Another example, a moving car. Okay, the position of the car is changing with respect to the parking board, right? Parking board. Then we can say that the position of the car is changing, or the car is in a state of motion, right? That is state of motion. Then come to the state of rest. What is state of rest? If the position of an object does not changes with respect to a fixed point, then the object is said to be in a state of rest. Can you send any example? If the position of an object does not changes with respect to a fixed object, then the object is said to be in a state of rest. Example, see whiteboard. See this board, this whiteboard. The position of the board is not changing with respect to the wall, right? Because the whiteboard was here yesterday, now also here, the position is not changing, right? So that we can say that the whiteboard is in a state of rest. Okay, so state of rest means if the position of an object does not changes with respect to a fixed point, then the object is said to be in a state of rest. So, okay. Now we have distance and displacement. Distance. Now we have distance and displacement. What is distance and what is displacement? Is it same? No. Right? Suppose consider 2 points A and point B. Okay? Consider 2 points A and B. You are at the point A. Okay? You would like to go to point B. In front of you, you have many paths or many ways. Right? So one is this one. So first path, okay. Second path is this one, okay. Then third path. This is a third path, okay. So to go to point B, you have 3 paths here, right? Or 3 ways here. 1, 2, 3. Out of this, which one will you choose? Of course, the second one is, right? Why? Because this one is, if you are choosing the second one, you will reach very fast in point B, right? That means this is the shortest way, right? Among this, it is the shortest way, okay? So all these are the distance, okay? All these are, that is 1, 2, the path 1, 2, 3 are the distance, okay? And the path 2 is the displacement. Okay. Then what is distance and what is displacement? So distance is so I told you all this. So distance is the actual path covered by the object, right? actual path covered by the object. That is what is called distance. Okay, they have many value. Because see, here it is 3. The distance between A and B, 3 points are there, right? Okay. Then what about the displacement? See, here I told you that the second path or second way is only the displacement. Then what is displacement? What is the displacement? The short, before you were here, now you are here, right? So this is your initial position, this is the final position, right? Okay. Then displacement means the shortest distance between initial position and final position of an object. The shortest distance between initial position and final position of an object. That is what is called displacement. Okay. So now you got what is distance and what is displacement. Alright. Now let us see the difference between distance and displacement. Distinguish between distance and displacement. Okay. First one. What is distance? First point is actual path covered by the body. Actual path covered by the object, right? Here, shortest distance between initial position and final position of the object. Shortest distance. Shortest distance between initial position and final position of an object, right? Okay. Now, what is the second point? Distance is scalar quantity, right? Scalar quantity. Distance is scalar quantity. What is scalar quantity? Scalar quantity is the physical quantity which have only magnitude, only values, right? So what about this displacement? It is vector quantity. Vector quantity, right? This is vector quantity because it have both magnitude and direction. Displacement have both magnitude and direction. Why? Because if you are going that in our example, if you are going to 2, the path 2 only, you will reach fast, right? So that is direction, right? So displacement you have direction. Then what is the third difference? It has only positive value. Okay, it has only positive value. What about the displacement? Can be positive, negative, or even 0 also. Okay, even 0 also. Positive, negative, and 0. 0 values. Okay, then the fourth one. Depends on path, right? It depends on path. So we have seen that three ways. So if you are choosing, that is the time taken by you is depends on the path you are chosen, right? So if you are going through the second path, you will reach very fast. If you are taking first path, it will take more time, right? Okay, so it depends on path. Then what about the, here it is independent of path taken by the object. Okay, then the last one, fifth one. What is the difference between fifth one? Fifth one is it is equal or higher than the or more than the displacement, right? So displacement itself a distance, so it is equal or higher or more than the or higher than that of the displacement. Okay, here okay, here it is equal or greater than, that is distance is equal or greater than displacement. Okay, so what about the displacement? It is equal or less than distance. Displacement itself a distance, right? But it is less, equal or less than distance. Okay, so these are the difference between distance and displacement. First of all, that is first difference is actual. First of all, the actual path covered by the object. Then distance column, it is the shortest distance between initial position and final position of an object. Second one is distance is a scalar quantity, right? And displacement is vector quantity. The third one is the distance has only positive value, right? And the displacement have positive, negative, or even zero also. Then the fourth point is distance depends on path taken by the object, right? And here in the displacement, it is independent of the path taken by the object. Then the distance column, it is equal or greater than the displacement. That is, distance is equal or greater than the displacement. Then here it is, displacement is equal or less than distance. Okay. So this is the difference between distance and displacement. Now we have uniform motion. Okay. So what is uniform motion? Let us consider an object is moving and the position of the object is changing with respect to time. Okay. Let us write the displacement of the object in different time in a box. Displacement, okay, time, okay. So at a time 0, okay, displacement here it is 0. At a time 1 second it is 10 meter, 2 second it is 20 meter, and 3 second it is 30 meter. Okay, right, take one more reading for 40 meter. Okay. Now, so we got the displacement of the object in each second. Let us draw in a graph. See that here it is displacement along y-axis and time along x-axis. Let us mark 0, 1, 2, 3, 4. Okay. Here it is 10, 20, 30, 40. All are in meter. Here it is in second. So let us mark. See that at 0, time 0, displacement is 0. Okay. Now here at a time that is 1 second. After 1 second, what is the displacement? 10 meter. 1 second, 10 meter. Here it is. Okay. Then after 2 seconds, 20. It will be here. Okay. Then here it is after 3, 30. Okay. Then after 43 here. See that. Now join this. See, join this. Then you will get a straight line, right? Straight line. Okay. So this is the uniform, that is a displacement time graph of a uniform motion. So displacement time graph of a uniform motion is straight line. And what is uniform motion? Here you can see that in each second. See, 1 second it covers 10 meter, right? Then after 2 hours, that is after one more second, it covers 10 meter again. So that means in each interval of time, each 1 second, the object covers 10 meter, right? So that's what is uniform motion. Then what is uniform motion? If an object covers equal distances in equal interval of time, then the object is said to be in a uniform motion. Here you can see that in each 1 second, in each second, that is object covers 10 meter, here 10 meter, here 10 meter, right? Okay, so this is known as uniform motion. If an object covers equal distances in equal interval of time, then the object is said to be in a uniform motion. Okay. Now let us see that what is non-uniform motion. Okay. So let us consider another body is moving, and let us mark the displacement in each interval of time. Okay. And we can have in a box. Okay. Here displacement. Okay, here it is time. Now 0 time displacement is 0. After 1 second it covers 10. Okay, then again it is covers, it is after 2 seconds it will be 15. Then after this third it is 30. Okay, Then after one more second, that is for it is 35. Okay. Now let us go in a graph. Okay. Here it is displacement. Okay. Here it is time. Here it is 0, 1, 2, 3, 4. Okay. Here 10, 20, 30, here 40. Okay. Now let us mark it. So first 0, the start time 0, displacement is 0. Okay. After 1 second covers 10 meter. Okay, 10 meter. Then after 15, sorry, after 2 seconds, it goes 15. Here it is. Okay. Then after 30. Okay. Okay. Then after 4, it will be 35. See, when you're combining this one, combine this point, you can see that it is not straight, right? It is a curve. It is not straight. And you can see in a column also. See here, after 1 second, it covers 10 meter. The next 1 second, it covers 5 meter only. Next it covers 1 second 15 meter. Okay. Next second it covers 5 meter. Right? So you can see that. So your time interval is same, but the distance covered is different, right? So that is non-uniform motion. Okay. So non-uniform motion means if an object covers unequal distances in equal interval of time. If an object covers unequal distances in equal interval of time, then the object is said to be in a non-uniform motion, right? If an object covers unequal distances in equal interval of time, then the object is said to be in a non-uniform motion. Clear? See that the displacement time graph of a non-uniform motion is not a straight line. Okay, it's like a curve. Okay, it is not a curve. Okay, so this is non-uniform motion. I hope all of you understand this session. You can download notes through the link which is given in the description box. We can meet in next class. Thank you.